Hello, everyone, and welcome to our webinar today. Today's session is being brought to you by Scale Computing, and we'll be discussing the path to virtualization excellence. Before we get started, I wanted to cover a few items in our console. This session is being recorded, so if you step away or miss any part of it, you'll get a link in your inbox to view it on demand. Also, we want to keep things interactive with you all, so use that Q&A widget on your screen to submit questions at any time, and we'll look to answer those towards the end. We'll get to as many as we can, and if we miss your question today, we'll follow up with you after we're done. Also, I do want to point out that we do have a handout available in the handout section. That's to the left of the slides. And then on the other side of your console, we do have the attendee chat. You can pull that up with the icon buttons located at the bottom of your screen. So jump in and start conversations with fellow IT pros. So let's get started with the introduction of our speaker. Matt McPhail is an IT storage and virtualization expert, having worked as an infrastructure architect to build proven solutions for the past 20 years. He currently serves in a leadership role as the Global Director of Systems Engineering at Scale Computing, where his team assists clients with storage, IT, and virtualization needs across the globe. And with that, Matt, I'll hand it to you to get started.
Thank you so much, David. So that was a mouthful. Again, my name is Matt McPhail. Basically, what I do on a day-to-day basis is talk with people like you. So Spice says, I really appreciate you joining, especially Death by Band-Aid. That is an awesome handle. So thank you so much, everyone, for joining. So the path to virtualization excellence. So I'm going to cover a couple topics today, and they're going to be around the benefits of virtualization, why modern virtualization can be complicated, and the advantages of scale computing to a virtualization platform. So I got to do some housekeeping. I understand that this could be taken as a intro to virtualization course. This could be taken as a very high level course, but knowing your community, and I want to be true to your community, I'm going to try and go a little bit deeper than what a normal introductory course is, but yet still maintain a kind of in between of the introductory and the deep dive. I've got 20 years of doing this. A lot of these topics I could spend an entire hour just talking about one slide, but I want to be true to the course material, but I also want to be true to you guys too. So how you can help me is, as David said, if you want to hear more about a specific topic, ask me a question. If you want to hear a higher level on a specific topic, I'm going a little bit too deep, ask me the question at a higher level. Just the clarification is great, and I've got a Q&A chat window up in front of me right now that I'm going to use to try and cater as I'm walking through this. All of the questions will be answered by the end of the conversation, but if I do have a break and I'm able to make this interactive, please help me out with that. So with that, let me start at as close to the beginning as possible. Obviously, I'm not going to go back to the very beginning, which is the 60s and IBM and basically the invention of virtualization. But what I am going to talk about are the specific benefits. And I'm going to hit these at a high level because a lot of you have seen these and you've had these drilled into you. But I'm also going to talk to them from the standpoint that you really need to know and think about these as you're building out your budget if you haven't done it already. So the first and obvious are three key components when it comes to virtualization. You're going to see benefits in each of these three areas if you virtualize. If you've already virtualized, you've already seen benefits in each of these areas, especially if you've built it out using best practices. First of which, most straightforward, and the one I like the best is simplicity. I was an IT director before virtualization became even mainstream, and when I embraced virtualization prior to coming to Scale, I actually worked for VMware for a time, and I used virtualization at previous companies to that. The number one draw for me was simplicity. Simplicity of user interface. Simplicity of a single piece of software that can basically manage all the key components. The simplicity of being able to have one throat to choke. when it came to where all my needs were met. And then something that I actually had the ability to learn and grow and build some training off of. So the second piece, and what helped me take vacations, what helped me sleep at night, was the availability option. The number one is obviously high availability. I've got a couple servers that I can put together and have them attached to a SAN. I want to do that, especially I've got a robust enough network that you have these days. There's no reason why it can't be done, and virtualization can certainly help out with that. And the critical thing to build upon that, such that not only am I able to go on vacation, but I don't have to worry about resume generating events, is backup and replication. I can do that easier when it comes to virtualization. There's a lot of tools that are built in. There's a lot of tools that can allow me to build a simple and easy to build a runbook. There are tools that allow me to connect to disparate or hybrid extra sites, or building into an edge or a cloud deployment, which I'll talk a little bit more about later. Backup and replication is just simply, back to the first point, easier when it comes to virtualization. And then obviously the highest bit of that availability is the DR as a service, where it doesn't even have to be my gear. It can be someone else's gear that I'm just leasing in order to be able to do that. Or I can build an actual service out that is monetized around the availability of the virtualization platforms that I'm using. Last but not least, scalability. You can go from a single node, that's a free instance if you want it to be, that can be your first time virtualizing. If you wanted to even set up a sandbox, you could do that. My first virtualization effort was on a piece of software called VMware Workstation on eMachines platforms back in the day. I mean, it is super easy to start with a single node. But then from there, you can go into mix and match, where you can use disparate bits of hardware. You can have the hardware in different locations. You can have hardware coupled with storage, coupled with other software that helps out as all for the singular benefit of handling your applications. Because at the end of the day, virtualization is a tool. It's a utility that allows you to have a better focus and less break fix around the applications that you're having to worry about and that are making your company's money, whether it's your own company or it's the company you're working for. Either way, that scalability and mix and match is there to provide that benefit. So drilling into each of these a little bit more, first of which, the backup and disaster recovery situation. You can have a primary site that has specific VMs that are talking to a secondary site. The secondary site can have less hardware that's running at it. It can have powered down hardware. It can have a single node with a whole bunch of storage. As long as you're able to run critical applications such as DNS, Active Directory, the ability for you to have a file and print, and potentially a database that is handling specific transactions, you're golden. You're not done working. You may be putting in overnights, but you're at least up and going, and traction and business can continue to run. And through that, you've actually got the ability to do rollbacks through the use of VM level snapshots. There is VM level replication that's going in between the two, either block-based or byte-based at the file system layer. And you actually can set up and you can monetize around and go to your bosses or your boss's bosses or yourself if you are the boss, a recovery point objective and a recovery time objective associated with how quickly and how much data that you're sending across from the primary site to the secondary site. Easy peasy. From there, what you also have is that you've got that ability to go down to that single node. And that single node is powerful. You may not think about it because it could just be a sandbox that you're using, or that eMachines that I was using back in the early days of virtualization. But that system can be used for a lot of different things, primarily of which you've got that backup and DR that I've just talked about. You can have a huge amount of storage sitting in a single node these days, especially if it's a single node you want to pay a little bit extra for. I mean, the amount that you can put in an NVMe these days, it's insane. That can just be used for a critical application that needs to be run at a single site. And at that single site, it could actually be distributed. You can do a hub and spoke model of a huge production environment to a bunch of single nodes. We have actually got a customer in EMEA that does exactly that. They've got a NOC that runs all of their production workloads, and they've got 1,000 single nodes that they've sent out at retail stores that they will then update with new VMs that they have produced from their NOC, replicated outwards, and then all of that retail data, whether it's camera data or POS or systems data associated with sensors or the employee time clocks, just gets sent back as data directly to that NOC. Again, something that is powerful, even though it is so small, that a virtualization allows for. And you also have the ability to, the natural progression of those nodes of DR is virtualizing in the cloud, or as our CEO likes to put it, virtualizing on someone else's server. Because really that's what the cloud is. You're talking about the ability to pay for someone else's server time, server resources, network bandwidth for you to be able to not have to host it on your own. And it's great. The ability for that is that you've got that rapid deployment. You've got that easy to scale, easy to manage solution that you've got on-prem, but then you can do a lot of that on your cloud platform as well, where everything's pay as you go, there's elasticity, it's going to be straightforward, easy to manage through a user interface. And of course, as much as cloud providers can claim, it is going to be highly available. So question just came in, I really appreciate it. With distributed enterprise, would this be helpful for a remote office of 6 users? The answer is, I've seen retail stores with 2 users deploy virtualization, and as long as those 2 users are managing specific data that is critical to the central office, then yes, it is very key, especially if you're going to build in HA associated with that. Now, with 6 users, you may not have the budget to build in HA. You may have only the budget to build in a single node, but even then, you're going to have some availability built into that single node that allows for virtualization to be sent back and forth, and for the flexibility aspects to justify having that node deployed. But great question, thank you. So the natural progression of the cloud then becomes edge. Now, edge is kind of still this nebulous thing that's coming out there. There are a lot of different definitions for edge right now, but basically the edge as defined, at least what we've seen internally, is anything outside of your normal data center. Any type of resources, any type of workload, anything that is not in a traditional data center that you can manage. Pretty simple. Custom built apps, IoT apps, multi-system management apps, anything that's distributed, manufacturing, medical, or just simply not in a standard data center in a closet somewhere. So with that, those are the benefits. And there's so many more. Each of these is its own topic that you could talk about for an entire one of these presentations. So the challenges, though, and what we're seeing is that there's a complication that's set into, quote, modern virtualization today. And the reason why is because of how it started. So when we're looking at it, how did modern virtualization start? Well, it started with the SAN. I mean, the first SAN that I ever got, it wasn't for virtualization, just for a database. Just so happened that I had the SAN, and I continued to get a SAN, that when I moved to virtualization, I actually was able to run it on a specific LUN within the SAN. Now, that database continued to grow. I continued to leverage it for virtualization. It certainly made it easier for the use of those other aspects, but that SAN was already in place when I went to virtualization. And from there, obviously I already had a file system that was associated with that SAN, a specific piece of firmware, and that firmware then gets associated with that underlying block storage, whether it's an object store or a block store or a specific fiber that's there. And each of those specifically have to have some form of networking associated with that. And the networking, again, that was something that was already there. something you'd already been managing, something that was critical to the infrastructure, but now it's intertwined into why traditional virtualization infrastructure is so complex. Because from there, what you have to do is you've got to deploy a management server. You've got to deploy specific servers that are associated with running the virtual machines. All of these which you currently have, but now you're having to buy more, and you're having to network them, you're having to connect them, and you're having to make sure that they have the proper connections, whether it's hardware HBAs or whether it's a software initiator that's associated with that. And you even haven't created a virtual machine yet. You haven't even created a LUN on the SAN yet. So first thing, obviously, is to create that LUN. You've got a object store on top of a firmware on top of an object store. And the first thing that happens is that LUN gets sent out to the appliances that are running the virtual machines, whether it's a specific piece of server hardware or an appliance itself. And from there, what's the first thing that happens? Well, a file system's installed on it. And that specific file system now attaches to that object store, which attaches across the network, which attaches to the object store, which attaches to the specific firmware file system that attaches to the rated object store that's the hardware of the SAN. Again, what we're doing now is the first thing that's put onto that file system is an object store, a specific file that holds all of the objects that are associated with that virtual machine, whether it's a VMDK file or a specific VACX file that's associated with Hyper-V. And that is there to ensure that that's handled. And then finally, you get to create that VM. But what's the first thing, of course, that you have to create when you create the VM? A file system. In order to put the OS on, the file system is created first, and then finally, you're able to get to that application. So now what you've got is an infrastructure that is so complex that you've got an application that has to run through file system, on an object store, through a file system, on an object store, across the network, to that actually object store that's associated with that specific LUN that is then across a specific piece of firmware or file system that is then connected to that hardware rated raw object store that is actually physical. Not your fault. You already had those materials around. That's what hardware required. That's what the software is built for. It was built for something that has already existed. Problem is now you've got the issue of multiple vendors. You've got multiple support contracts. You've got the ability for a integration time that has to be slower because you've got to integrate pieces that are associated with the SAN, or pieces associated with network, or pieces associated with the specific software or the management layer or the servers, even before you can actually update the VMs to make sure they're on the right versions. And with that comes more expertise. And the expertise, even though you're getting training on it, it still makes it harder to scale. And then every piece of it requires software licensing associated with that. So on top of it, you do have some backup associated with it, but not all. So a lot of times you have to get a third-party backup disaster recovery tool in order to mitigate that as well. So a lot of those benefits that I talked about in the first section get muddied because of the complexities associated with it. And unfortunately, because you may not have enough budget to handle all of the specific costs needed to get all those benefits. Because unfortunately, it's not 2010 anymore. I'm sure your bosses want IT infrastructures that aren't complex. They don't want to look at that 3-2-1 solution, or what our lead software architect calls the inverted pyramid of doom. It's actually getting to the point where with the cloud offerings, with the edge offerings, your jobs are having to revolve and evolve around a more data center less or data center light involvement of compute. I defined that earlier as edge computing, but you can define it as whatever you want. Honestly, you could define it as having to spread your time more on break fix because you're having to have more compute in places that unfortunately will have more downtime associated with them because they're not as easy to use as a data center or nor have as much uptime. And what's the solution? it's really more efficiency. It's all of those benefits at the beginning. It's smaller, more affordable solutions, and that's really what the market's driving for. So when we look at it, the virtualization market is kind of flatlined when it comes to traditional virtualization. It's really flatlined on the reference architecture. It's kind of growing slightly when it comes to integrated, but really what we're seeing is that, and we're near the tail end of this curve, we are seeing that hyperconvergent systems are actually outpacing every other system that's in the marketplace right now. And the obvious question is, for those of you that may not have hyperconvergence, is, well, what is it? Well, just quickly, for everyone that has deployed this, hyperconvergence itself is the integration of compute, storage, and virtualization layers. Let me say that again. It is the integration of compute, storage, and virtualization layers into a single solution, meaning it's not a separate hypervisor or a separate piece of storage or a separate server. That's integrated. That's convergence. Hyperconvergence is when you have the software layer all the way baked in, and it's one efficient stack component in part with the servers, in part with the storage. So how did we get there? Kind of goes back to what we were already talking about. It's, you go from the traditional approach where you've got different servers, you've got different software, you got different switches, you got different management tools, again and again and again, to, don't know if any of you purchased FlexPod or vBlock back in the day when it was a converged offering, but that really came down to the process of being able to put everything at least in a rack. Still had to buy the software. You still had to get it installed. You kind of had a reference architecture depending on how you purchased it, or you could purchase it maybe all in a bundle, but it was still separate line items depending on it. And I see the questions coming in. I will definitely get to them as I'm going through. So where we're at is you go from that to a hyperconverged solution where everything's in the server. It becomes a true appliance, whether or not it's something that you are purchasing as software that you're putting on a true appliance, or you get it as a fully converged appliance together with compute memory, storage, and virtualization. And obviously, it's going to be there to create a software-defined data center. So with that, when we look at the traditional HCI vendors, there still becomes a complexity problem. So when you're talking about a traditional HCI vendor like Nutanix, for example, Nutanix has done a great job in the marketplace. Never do I want to say anything negative about a peer. I just want to point out facts. In order to have disparate hypervisors in a platform, because Hyper-V, because VMware is closed source, meaning you cannot handle or you cannot manipulate the stack, every hypervisor vendor allows for it to be installed onto a VSA. Now with that, you do have some flexibility, but you've got a lot of efficiency loss. So when you're looking at a traditional hyperconverged appliance, and when you're creating a VM, you can see the VM teeny tiny up there at the very top. Now you can see the VM's path if it has to change a period to a comma. It has to go all the way through the node hypervisor, all the way through the VSA compute layer, up through the actual physical storage layer, through that physical compute that's associated with the layer on the firmware. It has to then go back through the VSA firmware and then across the actual compute that's associated on that VSA through the virtual storage appliance. So that virtual storage now becomes where the storage occurs. And then it has to go all the way back through for a commit. And then it actually has to go through the ability to do a mirror from that node hypervisor across the network, then through all of the same steps again. Node hypervisor to VSA compute, through physical storage, through the actual firmware, down through firmware on the VSA, and in the physical realm back onto the virtual realm storage. Again and again and again. So big differences. And I'll talk a little bit more about these with us. Big differences are around, you have to have caching with this. You have to have a high performance disk. You have to purchase extra hardware, because the hardware that you get, the amount of raw hardware is different from the amount of usable hardware that you can. You can see there that anywhere between 96 and 300 gigs worth of RAM could be consumed by that underlying VSA, and 12 cores consumed across an entire cluster. So physical differences are the main things, and then a lot of it comes down to that complexity that's there and the simplicity that's associated with that. So again, all of these solutions are going to be extremely complex with that. So going into that, just a few more slides, and I'm going to actually jump into a demo. The advantages of us, and I've already talked a little bit about that, from our perspective when it comes to virtualization in a hyperconverged environment. Number one, we add to those use cases. The simplicity aspect, we're going to add the fact that we actually have pre-configured storage underneath the covers. We're going to add in the fact that everything can be deployed in less than an hour. An availability perspective, we actually have patented self-healing algorithms that are under the covers to do break fix so that you don't have to. A lot of things associated with software can be attributed to things that have happened before. You know it because you fixed the same thing over and over and over again. What we've done is we've actually coded in state machine algorithms to fix it for you so that redundancy can be fixed, so that specific software can restart services, so that HA can be programmatically put in, so that resources can be shared in a live fashion. That way you don't have to worry about it. Your individual time is spent on more important items. And quite frankly, back to the thing that I said earlier, it's because infrastructure is a utility. We're not the sexiest part of the network. We're not the sexiest part of the entire environment. We're in fact the least. The most important and the most sexy is your time spent with the actual money-making applications. I know this because I'm at fault for saying the other thing when I was at VMware. My apologies on that. This is a group therapy session. I tried to convince you when I was at VMware that infrastructure is sexy. It's not. Infrastructure is there as a utility, just like you turning on a faucet to get water out of, or you plugging in your laptop to get power. You don't have to think about where those two things are coming from. You just know you're going to get your thirst quenched or power for you to be able to play video games. Quite simply. That you have the ability for scale out, seamless. So you don't have to worry about any downtime associated with that, or updating firmware in a non-rolling fashion, or having to worry about taking VMs down. It's just simply there. And with that, with the ability to take all of these things and put them together, you gain a fourth aspect. You gain the affordability aspect, where you've got a complete stack that there's no software licensing associated with that for the virtualization layer. And because of that, you've got lower prices and lower costs associated with that. That is truly what differentiates ourselves from the competition, and a few of the other ones that you're looking at comes down to the architecture. Because we can hit all of these specific aspects, we have an architecture that moves from this, which is the traditional infrastructure for virtualization, to this. Every single one of the nodes connects directly to the storage layer, such that when you change a period to a comma, instead of doing 14 hops like you saw on the previous slide, you're doing 3 hops. The benefit is that you've got a direct line from the hypervisor memory all the way through to the storage memory. So we see an efficiency of 60% over all of the other hyperconvergence vendors. We see the ability to have uptime much greater. We see the ability for you to create a VM and be able to manage the infrastructure in just a few clicks after it's only taking you less than an hour to deploy. And most importantly, the hardware that you purchase is the hardware that you get to use. Because instead of consuming 96 to 300 gigs worth of RAM and 12 cores, you consume less than 12 gigs of RAM for an entire cluster, 4 gigs per node, and a fraction of a core. We're talking about 3/10 of a core, because each time you're using 1/10 of a core of actual compute for each of the different nodes. And a lot of our customers honestly run an entire remote office or SMB data center on what it just requires that 12 core and 96 gigs worth of RAM to boot on the other ones. So with that, I also want to shout out one of the advantages that we have, and it's it's you. It's absolutely you guys. So Spiceheads, number one, front and center. You guys have given us a 5-star rating on Spiceworks. So thank you. Thank you, thank you, thank you. We're one of the reasons that you are one of the reasons that we've become an advantage in this field. So again, this is on you. I really, really appreciate being able to talk with you right now, because from the standpoint of what you see here, it's been proven over and over again. So if you do have questions or you do want to learn more about what we're doing after talking with me, by all means, go and talk to your community members, talk to anyone on the forums just to see what their experiences are like. You can see that we're very, very proud of this. There are these other guys, but this being a Spiceworks forum, I'm not going to bring them up right now. So with that, I did save some time to go through a demo. Now, my apologies. If you want a more comprehensive demo, you can feel free to schedule it with someone internally. We'll be more than happy to help you. But I just want to just be able to share my screen and go through a quick demo just to be able to show you exactly what's going on. So with that, everyone should be able to see my screen okay. Just a moment. And you can see here, here's the interface. It is just a web-based interface. You don't have to know KVM, which is what we're running behind the scenes. You don't have to know any of our HyperCore OS infrastructure. There is training available, but quite frankly, it's really straightforward, and it's something that you can really do on your own. Because as simple as creating a VM is as easy as you going in and just clicking on the plus button, giving it a new one, new name. I can give it a description tag, but really, actually, I'm just going to give it a couple more drives. I'm going to tell it that I wanted to boot from Windows deployment, 2019. And click create, and I'm done. I didn't have to do anything with storage, didn't have to do anything with the networking. I didn't have to wait on my caching algorithm to create this through the VSA. I didn't have to go through 14 hops to be able to do it. Quite frankly, it was just it was almost instantaneous. Now, I got this VM here. I've got the ability to change it as I need to. I can hot expand the drives if I want to. I can do the ability of doing file level restores if I want to based on snapshots that are here. But in actuality, what I want to do is I just want to power it on. So I talked about those self-healing algorithms. Right now, it's actually invoking one of them, and that's the one that finds the node with the most available resources. And when it finds that node, it's actually going to power this Spiceworks VM on that node for deployment. And you can see that once it's deployed, it actually has the ability to be consoled in within just a matter of seconds. So looks like it was deployed on the first node in the cluster. See it right there. I can console into it, and guess what? Something you've probably seen 1,000 times, which is the installation of Windows. So my apologies on that. I won't stay on the screen too long. But basically, you are able to get to everything that you need directly from within this interface, within the console itself. And you can control everything from within the console, Control-Alt-Delete there from that as well. But back to this VM. This VM now is a running live copy of all the data that you've installed directly on it. So if you wanted to, you can actually take a clone of it. I'm going to clone it right now. I'm assuming that it's got 2019 installed on it and everything that I need to create a database. I'm going to create that database, but as you can see here, the drives are not at all big enough for a database. I'm going to give this one a terabyte. I'm going to give this one half terabyte. I'm going to click clone, and I'm off the races. So you can see what's happening behind the scenes. Again, the self-healing algorithms. I've got a block engine that manages the entire storage stack. So we don't use RAID. We use a replication factor of 2 that does a striping mirror between each of the different nodes in the cluster, and it actually then is able to track all the blocks. So that database was created off of this specific Spiceworks VM, and the database is actually just a differential of the Spiceworks VM. So you can see here, if I go back into the snapshots associated with that, those snapshots are only as big as the change data. My clone source database is 0 bytes in size because I haven't installed anything yet on Windows. Now, I can continue to do that again if I wanted to, just by clicking another snapshot. You can see the snapshot is nearly instantaneous again because I'm not doing anything. The system itself is efficient enough to know that I don't have to do a parent-child relationship. My database isn't associated with a specific snapshot that's associated with a file system that has a performance loss every single time you take a snapshot. It's just simply a bookmark that's associated within the specific VM metadata itself. So I could take 5,000 snapshots and still supported by us internally because the snapshots really aren't doing anything than adding reference counts to the underlying storage blocks. So those metadatas are not getting very big at all. But you can see snapshots themselves. Looks like the initial master boot record was installed on Windows after the snap. So you can see my differential is 3.15 megs. And if I wanted to, I could actually go in and I've got a capacity allocation associated with each of these. If I wanted to add another drive, I could do that based upon the exact restore point of this. So say this is my C drive, I could add another one here, or I could add it to any of the VMs that are currently on this appliance. We have a lot of them. This is a test bed that I have for my systems engineering team so they can do all sorts of stuff. But file level restore is just as simple as that. It's being able to click on the specific VM that you want to restore to and then pulling it directly back off the file system. Pretty easy. Now from here, you can see the differentials. You can see everything that's going on. I've now got that database. If I power on that database, you've got the ability for it to, again, invoke those self-healing algorithms that are looking at specific state and finding the exact state that has the most available resources. Likely it's going to be now on node number 3 because that has the most available resources. See there, it has been set up. It's now started. And what we can do is we can do a couple of interesting things. We can do, because of those efficiencies built around the storage and the fact that we can see everything that's going along the storage, we can actually have pre-built-in backups and we can have pre-built-in performance. So for the database, let me show you the performance first. Now, if I go in and I look at each of these different drives, you can see that it did do a drive expand for me. Didn't have to worry about that. I've got 100 gigs, terabyte, and 500 gigs. So for that 100 gigs, excuse me, man, you can see my age, my apologies. The capacity at 100 gigs likely is going to be there just for the C drive. So we've got the ability to set up priority based upon hot blocks so that whenever writes are occurring, that they're going to be put onto specific high performance disk. That high performance disk you can see here is an SSD drive. associated with a specific tier, and the rest of it is simply spinning disk that's SAS. So going back into this database, that 100 gigs, I don't want pagefile.sys hitting my SSD tier and taking too much performance away from it. So I'm going to turn this down to 2. And I'll update it, and now what I can do is go on to the next one. For the specific tier here, this is likely going to be my data drive for the database. It's going to have really hot data from transactions that are coming in and really cold data from transactions that happened 6 months ago. So I'm going to pop this up a little bit. Click update. But now, of course, for all you DBAs out there, where am I going to next? I'm going to that transaction log. I want to make sure that transaction log has as much of that SSD priority as possible. So I'm going to take this up from normal to high, very high, extreme, absurd, hyperspeed, ludicrous speed, and I'm going to leave it at ludicrous speed. Now, I love the fact that our engineering team has a good sense of humor and enjoys pop culture, because I too like Spaceballs. So when I look at this, this is the highest priority that I can give it to, and yet still allow the system to create a wait. What I mean by that is that the system itself will look at the last 1 million IO per virtual disk and determine what is hot and what is cold. And it will write based upon that algorithm. All of the hot blocks will go to SSD, all of the cold blocks will go to spinning disk. So instead of having to have a cache and having to use SSD data for a caching algorithm, like all the other HCI vendors do, we actually use it as actual storage for you to be able to leverage in a performance-based set. To the point that if you've got enough SSD, you can take this to 11 and put all of the blocks from this VSD onto SSD, or if we're talking about pagefile.sys again on the C drive, you can take it down to 0 and turn it completely off. All blocks only go to spinning disk. I'm going to put this back at ludicrous speed because the Schwartz should be with you. With this, you've got the ability to now look at this from a backup perspective. And I got a couple minutes before I want to take some questions. So just to show you backups, I'm going to go back to that Spiceworks VM that I showed you. And all backups are based around snapshots. So when you got the snapshots, you've got the ability to then go in and set a schedule associated with those snapshots. And this can be a backup schedule that's associated with the differential disk that you have set up. You can go in here, click on schedules. I'm going to choose one that's already pre-created. It's called critical systems. You can see here that I have a critical systems schedule that backs up every 15 minutes, every hour, every day, every week, every month. I could add another reoccurrence if I wanted to. I could add in a policy for every single VM that I have. You can see there I've got a lot of policies there. But I'm just going to cancel out of this and apply it directly to that Spiceworks VM. Selecting schedule, choosing critical systems, clicking on update. Now you have a local differential-based backup. Because remember, with these snapshots, you don't have to do full backups anymore. You don't have to do synthetics. You don't have to do incrementals. This is simply based around differential change data. That can then not only be restored full as a clone, but it can also be restored directly to a disk and do file level restores directly to any backup that is there. Or you can use a disk and create an entirely new VM directly off of this disk. Now, question remains, how does this handle with DR? Well, the nice thing is that based upon the same schedule, you can set up DR directly for it. By clicking on this, you can choose to replicate to an entire other cluster. You can choose to replicate to a single node, or you can choose to send it directly to a cloud instance. We've partnered with Google's Cloud Unity to where it is a seamless instance for you to be able to run HC3 scale on Cloud Unity. You don't even have to have a Google account. It is actually set up with a layer 2 switch so that it looks seamless and part of your LAN, even though it's sitting out on Google's cloud. For this instance, I'm going to just simply click on a single node, click replicate, and it's just a couple clicks, And what it does now is it does a local snapshot. It sends that local snapshot directly across the wire, and that local snapshot then allows for you to be able to have that remote snapshot there and all the data being sent across. So if I was to move over to that remote office branch office server, you can see that I've got it all automatically queued up here, and everything is moving across. There's my Spiceworks VM, and everything is being snapshotted and replicating across right now. And if I wanted to, I can actually go into one of the other VMs here and just show you that restores are just as easy as going back into the snapshot or restoring directly from the latest clone. So this production SQL test, I just click on clone. I say that I want it to just be a DR environment, click clone, and it's, again, just a couple seconds because I'm taking those inherited blocks that are associated with that and creating a new VM out of it. I power it on. Once powered on, the only thing left to change is DNS for you to be able to do a full DR across. And with that, you've got the ability to not only do it here, but Failback is a cinch as well. Because again, because we can see all the blocks, when you set up replication back to the mothership, that production environment that I showed you at the beginning, it's just as easy to send back the data because the data is already there. Those self-healing algorithms are going to be able to say and see that, oh, you've already got blocks that are associated with this restore there. Let's just send the failover change data back to the original. Just that simple. So with that, you've got DR covered, you've got cloud covered, you've got the simplicity covered. And if I was to go back to my slide deck, I've got the ability now to handle a number of things. To close, with this, you get the single vendor support that you need. You get integration time that's minimal to zero. You get no infrastructure expertise needed. You actually just got trained in 80% of the interface right there. It will scale seamlessly just by adding in a new node and being able to handle the system quite easily with no downtime, and everything from software licensing and disaster recovery is built in. So with that, I went over by a couple minutes, but we still got about 11 minutes time for questions, so I'm going to tackle those. Just a reminder, I got my Q&A chat window up, and so I'm just going to take these as I see them up at the very top. So first of which is, can we replicate across sites? The easy answer is yes, absolutely. You can replicate internally. You can replicate to separate sites using an entire cluster. You can have another site that has a single node. You can actually replicate directly to a cloud offering if you wanted to using our Google Cloud instance. So all of that is covered. Great question for the second one, which is, can you deploy a virtual desktop infrastructure? Yes. Yes, you absolutely could. Due to time, I wanted to include that as one of the benefits of the ability to do virtualization, but I cut it just for time. My apologies. But yes, you can absolutely do that, which is one of the benefits of deploying virtualization in general. Next question, can you DR backups to other offices and spin them up there? Yes. I mentioned that retail deployment earlier. That retail deployment does exactly that, where they actually spin them up at the retail sites if they need to, or they'll have another retail site if the original goes down, manage the transactions for them until they can bring that back online. So great question. So next question is, starting from scratch, is there a chart guide that can help procure equipment to virtualize a small office? Yes, 100%. We've got best practices guides that are associated with it. But honestly, the benefit of doing this from an HCI perspective is we've got specific hardware that you can deploy software on if you wanted to do it that way, or you can just deploy single appliances. So great question. So I answered the question with regards to how we are regarding Nutanix from a comparison perspective. Basically, when you look at HCI, ask yourself a couple of things. Am I getting what I'm paying for? Am I able to deploy this and know that the price that I'm getting for it is going to be the same price in perpetuity? And can I deploy this and have it run in a production environment in less than an hour with no tuning whatsoever? I would look at those things as a true comparison between the older ways of doing HCI and true hyperconvergence. So great question. So really specific question, so I appreciate that. Has scale computing been validated by a Metatech, or is it in the process of being validated? I believe we do have customers that are running Metatech, so you can reach out to local sales reps for that, for reference customers. We can certainly help out with that. Let's see, other questions, what we got? Thank you. Who does number 2 work for? You are exactly right. Thank you for the Austin Powers reference. I always enjoy pop culture. Other ones are, that one's done. And then another really good one, how do you migrate from VMware to your platform? The easy answer is that we've actually got tools. There's a really good tool called HC3 Move that allows for us to migrate from physical, from virtual, from a specific file to directly on the system. It's a byte for byte level restore that allows for minimal downtime for you to be able to do that migration. So it actually does a sync in between. It's a product that you're probably really familiar with. It's now called Carbonite Move that we OEM from. It used to be called Double Take. Let's see. Yep. Thank you so much for that question. And then I believe that covers everything but the resources. So, I mean, for people that are just getting their feet wet, please go to our websites, go to our peers' websites. You're going to learn a ton about virtualization and specifically hyperconvergence when it comes to that. So don't just go to Scale Computing, because you're going to get the Scale Computing story. Go to the Nutanix website, go to the VMware website, especially for people that just diving in. I mean, I was a sponge when I was learning this from scratch. I wanted to know everything about everything, and I eventually landed on VMware first as the product, and then when Scale came out, I jumped ship and moved over to Scale just because I saw the future of hyperconvergence, and I'm glad I did. My family's glad I did. I put my family's livelihood in the hands of Scale Computing, and it couldn't have been a better outcome. So for that, I think we got to every question. David, I don't know if you're still on live mode or not, but I think we've got everything there. But I really appreciate everyone's time. Hopefully this was valuable for you. It's certainly fun for me to do because I've done presentations like this in the past, but be able to tell the arc between initial virtualizations now to hyperconvergence with the little sprinkles of knowledge in between, I've really, really appreciated it. So with that, I will give you some of your time back. So again, David, the floor is yours.
All right. Well, thank you for your time today, Matt, and for going through that presentation and that great demo. We appreciate also Scale Computing sponsoring this great event today. So with that, I do want to thank everyone for attending. I do want to remind everyone that we are putting the winners of the contest in the attendee chat. So look for that, and we'll also have that in the community on the contest page. So take a look there as well. Thank you everyone for joining. We'll look forward to another partner webinar in the future. So until then, everyone stay safe and keep it spicy. Take care.
Thank you.